Evening all. How are we doing? Forgotten how to do this. Seems like forever since we did the last stream. Hello, hello. So it's not going to be a long stream, just a quick update on what I've been doing, why I've been doing it, and where we're at with it. And yeah, just any Q&A. So fire your questions my way and I shall do my best to answer them. So why don't we have a look at the most exciting thing, which is the new Galaxy stuff. So the first thing you'll notice when I hit play is the Galaxy generates instantly. So rather than generating the 27 sectors that we generate around the ship normally, it's now generating each stellar class in its own individual cells. So we have a multi-layered cell-based generation. It's not quite an oct tree because they're all treated individually, but basically each stellar class gets its own cell size depending on its absolute magnitude and radius and that sort of thing. So O-class, Wolf Riot stars, they have the biggest cell sizes and can be seen from the furthest distance away. It's around about 6,000 light years, the view distance for the brightest stars. And then obviously as you step down through the spectrum, the stars get more numerous and the cells get smaller. And the cell sizes have been separated out based on their apparent magnitudes. So so that we're efficient with the spherical culling of the apparent magnitude, we're doing a radius of 3 cells in a cube. So if you imagine kind of like a Minecraft sphere, that's kind of the shape of the cell generation. And what we've done is we've tuned it so on a radius of 3 cells, the apparent magnitude would fall at 2.5 cells away. And that's where our cull sphere happens. And the reason we're doing that is because as you're passing from cell to cell, we don't want any pop-in from stars that are being generated. So by making sure that we only render at 2.5 cells forwards, it means that as you cross the boundary into the next cell, it's then generating the next cell along in that direction. So you never get any pop-in as you're flying through the galaxy, and everything just fades in naturally from its apparent magnitude distance. The whole galaxy culling sphere has an apparent magnitude of 6.5, which is basically the limits of the human eyeball. So if you can see it with your naked eye, then the star is being generated and rendered. Anything that you can't see with the naked eye, it's not rendering, it's culling that before it gets to the sort phase, just to keep everything nice and performant. But what you'll notice, and I'm not sure how well this is going to show up with the YouTube compression, but this is space around Sol, and as you can see, that's the Orion Nebula right in front of us. There are 862 stars, which are basically exempt from culling. So those 862 stars are rendered at all times. And the only thing that will cull them is their apparent magnitude. So as you fly away from Sol, they will automatically cull when they can no longer be seen. But a lot of the stars that make up the known constellations are further away than our apparent magnitude culling will allow. So things like O-class stars can be seen from a very, very long way away, like 47,000 light years or something. And we can't set the culling distance that far. So for those particular stars, we just keep them live the whole time, and there's only 862 of them, so it's not going to kill performance too much. Everything else is generated in the cells. So if I just freeze the galaxy in place a sec, the cool thing with this is if I just change our speed, as we move from side to side, you can start to see the parallax of the constellations. And again, I'm not sure how well YouTube compression cope with this, but hopefully you get the idea. And if I then kind of fly away from this region, you can see that that's basically the area that we're generating. So you've got a wide circle of O-class and Wolf-Rayet stars, which are being rendered a huge distance away. And then as you step down through the stellar classes, they get denser and denser towards where the ship is. And obviously I've lost Sol, so we have no idea now where those stars are. The apparent magnitude culling, it kind of blends everything a little bit too much. So what I've done is I've overemphasized stars which are kind of around about Sirius's brightness and brighter. So I think Sirius has a brightness of, like, I think minus 1.5 apparent magnitude, if memory serves, and that's like the brightest star in the sky. So anything that brightness or brighter gets an extra little boost, so it stands out a bit more. And then a couple of the stars in Orion's belt are kind of like in the middling range, and I've emphasized those a little bit more as well, just to make those real constellations stand out a bit more, because otherwise it all kind of like mushes into just a bland star field, and you don't get that point depth that we need to be able to see the constellations. So there's a bit of artistic license there, but you know, it kind of helps spot where you are. Yeah, and as Claire points out, this is fixed a whole bunch of stuff. So one of the issues we had with the previous Galaxy gen was that the Galaxy was kind of, it wasn't rotated, but then it wasn't mirrored either. There was some issue with it where it wasn't generating the locations exactly where they should be. Orion's really the only bit I recognise, so I'll just point the camera at that. Oh, actually, you can see the Pleiades cluster there, that little blob right in the middle of the screen, and that will have a nebula around it as well. Actually, it's probably a good time to show this. So this is the shape of the galaxy as it now is. So previously we had basically a 2D texture, a grayscale texture that formed the density map for the galaxy. So what this does is this actually uses math to draw the spirals based on papers, like peer-reviewed papers from like 2019 onwards, which were built using the locations of H2 regions. So all these yellowy orange blobs here, those are real-world H2 regions that we know about. And I've only included the ones where we have known parallax data for them. A lot of them, we don't actually know how far away they are. We know which direction they're in, but we don't have distances. So where we don't have distances, I've not been able to include them. But they've used this for basically mapping out the shape of the Milky Way. So we've fitted our mathematical model to this, again, based on science papers. So the spirals are as pretty much as close as we can get to what they would be in reality. And you can see that the real world H2 regions kind of line up with the spirals as we fitted them, in terms of the log curve from the center of the galaxy. So things like the central bar is rotated correctly to Sol. Sol is like buried in the middle of that somewhere. But yeah, so it's got the right rotation versus Sol, and the root locations of the spiral arms are all correct in their correct position. And the Orion spur, oh no, there's Sol there, of course. And the Orion spur coming around here is where we are. This also takes into account the more recent study, which suggests that the outer arms are a lot wider out than we thought. So this is basically based on like the latest science that we have for the shape and scale of our galaxy. So yeah, it's the best it can be. The blue blobs are the procedurally generated H2 regions, and we're generating these essentially offline, and just rendering them to an array, the same as we do with the real ones, because we're using those to generate things like density of B-class stars and the presence of O-class stars or Wolf-Rayet stars. So if you and basically what we've done is we've taken the real world data, which is now 21 million stars, so we've increased how much real world data we have, and we've looked at the clustering of certain classes in correspondence with things like H2 regions. So those B-class stars will now increase in density around those star-forming regions. So you get this this natural ebb and flow in the density of B-class stars, depending on how far away they are from these generation regions, because they're quite young stars, so they wouldn't have travelled far. And again, you can see just the density curve as well, with the rings, spirals. I say rings because really they are rings. The dynamics that creates the pressure waves on a spiral galaxy is actually fascinating. Like, the spirals don't actually exist, and it was really difficult for me to get my head around this when I was doing this. Like, there's no such thing as a true spiral. What it actually is that the circular or the elliptical orbits of all the stellar matter, the stars and the dust clouds and everything, those orbits kind of coincide where the spirals are. So what you're actually seeing is orbits that get closer together and then pull apart as these objects are rotating around the black hole. So it forms a pattern that looks like a spiral, but the spirals are not actually physical objects in their own right. Otherwise, they'd wind tighter and tighter and tighter into a coil, rather than staying the same shape over millennia. Which is just something I learned. I didn't know that before, and now I do. So it's always nice to learn new things. But yeah, so all of that math has been ploughed into this. And that's basically the galaxy as it now stands. So I think we can confidently state it's a hell of a lot more scientifically accurate than it was. And the other cool thing about this is, because this is generated purely using math and not by using height map textures, it means that all we need to do is change the seed and we get a whole new galaxy. But that also includes the spiral pattern and anything else, like whether or not there's a central bar, whether there's any arms at all. So we can procedurally generate any galaxy we want, which means that yes, we can actually have multiple galaxies in the game should we choose to do so. So that's something that we'll look at some point. I like the idea of, once we've implemented wormholes, we can actually do wormholes to other galaxies, and we can include Andromeda and everything else. There's definitely an argument for and against that, because traveling to another galaxy is essentially the same experience. Like, it's the same procedural generation, it's the same algorithms. The stars in Andromeda are going to be no different than the stars in the Milky Way. Once you've seen one star system, you've seen them all. And other galaxies are going to be no different. So I guess we'll include it for the cool factor, but that's it. But it's nice to know that we have that capability now. We can generate any galaxy we want, and have as many as we want, which is good. Yeah, so that is that. The material that drives the Niagara particle. So this is just a really simple Niagara system, which is used for generating the point cloud for the stars. Before, we were generating an actual sphere mesh, a very low poly sphere mesh, and we were using a hierarchical static mesh instance, which means that you can draw as many spheres as you want, basically for the same draw call. But there was a lot of limitation through doing that. So by switching over to a Niagara solution, it's a lot more flexible and a lot more performant, which is good. And as you can see, we have that instant generation where like the entire galactic space generates like instantly, and we don't have the hitching and the pausing that we had before. One thing I do need to fix, which has crept in the last build, is as you travel, or have I fixed that now? Oh no, that is fixed now. No, it's not. Let's turn the freeze off. What it was doing is it was flickering. Oh no, perhaps I have fixed it. Oh no, we're all good. Yeah, so as we were moving through the galaxy, every time we hit the one light year boundary, the whole star field flickered while it regenerated. But I think we're good now. So if we zoom this way, you can see there that the field of stars kind of increases and decreases in density as we fly through the galaxy. And if we kind of keep going this way, we should find ourselves pretty much kind of in the galactic core, and you can see it's a lot denser and more packed with stars here. And again, I don't know how well this is going to show up on the YouTube algorithm, but you can see that the density of the star field is a lot higher here, and you can see it's going chugging a bit because there's so many of them. So the galactic core is still a problem to be solved in terms of performance. It's not terrible, but with that many stars, we might need to put a cap on the amount of stars we generate, because right now it's uncapped, so it can literally just generate thousands and thousands of stars in a particular location. But it looks cool. The nice thing, because it's generating things based on the H2 regions and the real distribution of stars, you actually see things like the Milky Way. Like if you're looking at the Milky Way side on, you can see that density layer where we are with the thin disk, which is nice. That's kind of forming automatically, and we haven't even added the volumetrics yet. So it's nice that just the density of the stars is just making the disk of the galaxy really obvious. I can probably also, if we just go into our settings a minute, let's turn on that. Can't remember whether I'm actually showing these or not. No, we're not rendering them right now. No, I turned them off, so we can't show. I was going to show you the H2 regions and how it generates the shape of the galaxy, but they're all turned off, so can't do that right now. But yeah, you can see kind of roughly here, you can see in the middle of the screen there's a definite like denser line of stars, and that's basically the galactic disk. But we'll start adding volumetrics to these H2 regions, and again, because we have essentially a map of where those H2 regions are, we can drive our volumetrics using the same location. So where we've got a star forming region, we'll draw a bunch of gas clouds, and that will help kind of generate the shape of the galaxy. Because the ultimate goal here is when you fly far up above the galactic plane, we want to see, you know, the grand spiral of the Milky Way below us, stretching out its full distance. As well as the galaxies beyond, because we have the data from that as well. So we can actually generate basically a static galactic field around the Milky Way. So you'll see other galaxies in the distance, which will be quite cool as well. Really kind of really sell how big the universe is, because it's mind-bogglingly massive. I'm going to answer a couple of questions in a minute. Yeah, so the missing star classes, like Wolf Riots and the Giant Stars, they're now in the game showing as points on the galactic map. So case in point, let me just freeze it a minute. Where is it? There. So that orangey blob right in the middle there, that is Betelgeuse. So that star right there, that is Betelgeuse. Now right now it only exists as a Niagara point, but it's there in the data, and it's there kind of when you look out the window. So one of the jobs we need to do is just make sure that it's spawned as its own class of star. To begin with, it's just going to be a sphere like all the other stars. I think Betelgeuse is quite lumpy because it's so big. So at some point we need to make a procedural mesh for really, really big stars that have non-uniform surfaces. But for now, Betelgeuse will just be a really, really big sphere. But you know, from a technical perspective, it's no different than any other star. It's just bigger. So we just need to scale the actor up. Magnitude 7 instead of 6.5. Sure, yeah, it's literally a tweakable value in the config. So I'm building our Galaxy Gen system, which I'm calling Genesis. I'm building that as a plugin, and the idea is that we're going to put this on the Fab Store at some point. So this is some of the config that will come with it, and we can change our apparent magnitude limit there. So it really is just a case of changing that to 7, and you know that's fully alterable within the plugin settings. So it's easy to change. Zarya, yes, I hope so. I mean, we've really like gone all in on scientific accuracy. So it's, you know, I say it cautiously, but we're probably the most accurate galaxy now in the gaming sphere. I don't have evidence to back that up, but my assumption is that we are probably the most accurate now. Certainly the most real-world stars. Obviously our database now is 21 million real-world stars and 7,000 odd exoplanets as well. And I don't think anything else out there comes even close to that. I don't like to brag, but you know, why not every now and then? Death is dead. Will we be able to visit the outer layers of gas giants? Yes. That is literally the full refueling loop. So volumetric gas giants is absolutely something we want. In fact, I can show you. If I can remember which map I built it on. Was it this one? Oh, it was this one. Yeah, so this is a gas giant, and it is volumetric. So obviously it needs work. It's not perfect yet, but yeah, it is a gas giant and it is volumetric. But you can see the tiling, and it kind of handles that in layers. So it does, you know, increase detail with distance, but yeah, it needs a lot of work. But yeah, we've started down the road of volumetric gas giants. So the refueling loop of the game is that you are ploughing through the upper atmosphere of gas giants, collecting gas to fuel the ship. We just need to get this right and work out what on earth's going on there. Why is there a huge halo? That better. Yeah, so you can see it a bit better without the volumetric fog messing everything up. But yeah, so the idea is as you plow down through the cloud layers, it just gets darker and darker and darker and darker until you are literally just inside the gas giant. But yeah, it looks its coolest just as you're kind of cresting over the edge. But as you can see right now, I've messed it up a little bit because the point at which it increases density is too close to the camera, so you can really see kind of pop in as it transitions between the low density and the high density noise volume. And also the shadowing isn't working right. Like, what we're supposed to end up with is like proper puffy clouds, but the shadowing is more density based. It's just not rendering the way I want it to. So yeah, there's work. I mean, we can't release it yet. It needs a lot of work. It does actually have like color bandings and stuff, so obviously this is a really boring one, but you can see here that the volumetric effect is actually being driven by a color map for the gas giant. I think I already implemented the seeding for this. Did I or didn't I? No, I didn't. Thought I'd expose the seed, but I haven't yet. So yeah, so it is seed driven, so it will change the color of the clouds and everything. But yeah, it's going to take a while to get this right. I won't be happy with it until, one, there's no tiling, because if there's one thing I cannot stand, it's tiling. Massively triggers me, so we don't want that. And the transition between the detail layers is a lot less obvious than what's happening here, because you can really see the transition, and I want to get rid of that. But yeah, so this should be the view you see out the window when refueling on a gas giant. You'll see all the clouds zooming past. So just working out where I was with the questions. So the wormholes in the game will be all over the place and naturally forming. The idea is that we're going to have stable and unstable wormholes. The stable ones, you'll be able to transition through them at any point in either direction. The unstable ones will only be one way. So you'll find an entrance to a wormhole. You'll have no idea where it goes. And once you go through it, there's no entry at the other side. You're just like out in the galaxy somewhere. So they're an adventure. You don't know where you're going to end up. They will be marked as stable or unstable, so there'll be plenty of warning if you don't want to go through it and get lost somewhere. And yes, and if we implement wormholes to other galaxies, which I really want to do, if we do that, then they will be big stable wormholes. So we'll make them big and obvious, and they will be two-way. The culling mechanism is only culling the generation of stars by their apparent magnitude. The galaxy as a whole will be represented by a volumetric effect, well, like this basically. So where we've got a volumetric effect basically in a sphere, we will have the same sort of volumetric effect in a spiral mapped to the spiral arms that we generate for the galaxy. So you'll be able to see an actual volumetric representation of the Milky Way galaxy at all times. Obviously, when you're in it, it will form what is essentially the Milky Way, in the sky. And as you fly up and away from the galaxy, you'll see the big grand spiral below you. Will you insert H2 regions behind the center of the galaxy? Yes. So obviously we're here and Sajay's there, and you can see here there's a clear detection line with the real world data. Now, obviously the real world data can't see behind Sajay because we can't see anything through the center of the galaxy, so we have no idea what's here in the real world. We can only extrapolate like where the spiral arms go, because like here we can extrapolate that they go round with the math. So all the blue dots are procedural, which is why there's no yellow dots, because we don't know what's there. So yes, there are H2 regions, but they're all fully procedural ones, not real ones. And we'll have all of these named as well. So when you're looking on the sensors, H2 regions will show up on the sensors, and they will be named if they have names in the real world. So that's going to be nice as well, going through like actual catalogue objects and being able to visit them, which I'm excited about. Thank you, Squirrelbait. Much appreciated. And yeah, I'm glad the cravings are going, Delta. The issues we were having with corruption are basically, they're kind of a moot point really, because we're building the whole system separately alongside the broken bits. So this is basically a whole new Galaxy gen. It's built using the foundation of the old one, so we're basically just converting what we already have to C++. But in doing so, we're getting rid of the inefficiencies and making it more accurate and more performant, and in doing so fixing a lot of the problems. So like I mentioned earlier, the real world stars being mirrored and inverted and just messed up in the data, that's all been fixed. The hitching every 1 light year has been fixed. The huge hitching every sector has been hitched, so it will no longer basically lock up the client every time you fly 100 light years. So all those issues we were having with the Galaxy gen, they've all been sorted now. And you know, the exciting part of that obviously is, whilst fixing it all, we've also massively increased the view distance to the point where we can now render real world constellations, which we couldn't do before. So it's, you know, basically game state broke, everything connected to it was bugged, so we thought, right, this is a great point just to rip the broken stuff out and not only fix the problem but also solve all the issues we had in relation to that at the same time, just to end up with a much better system. So we haven't just spent our time fixing a problem, we've spent improving it as well. Yeah, the save game's an interesting one actually, because right now the save system polls various bits of data around the game. Luckily, it only saves what you have visited. So the more star systems you visit, the more, well, not just visit, but scan. So the more star systems you scan, the bigger your save file becomes, because obviously it has to save that scan data. So it doesn't really matter how many galaxies there are or how big they are. It's what you touch is what matters for the save system. So that shouldn't change too much. When will you be getting an update? Yeah, that's the $1 million question, isn't it, really? When's the next update coming out? So right now I'm building all the individual pieces to this, and like with these, I mean, this won't be in the update because it needs a lot of work, but some aspects of some of the other stuff will be. So if we go to that map, these are just all my test maps that I experiment with. So this is the planetary surface test map. Anyone that uses Shader World will recognize this map because this is just the demo map that comes with it. hang on, sort my camera out. Come on, camera, slow down. Right, so here's our test shuttle. So the specifics of the flight model and the flight controller for the shuttle, all of that was the same stuff that was needed for sublight flight across the board within the game. So we had a few things planned for the next few patches. One of them was sublight flight, another thing was wormholes and multi-star systems and some extrastellar classes. All of those things are actually being covered by the work I'm doing right now. So in actual fact, I'm kind of working on 4 patches all at once, because all of these systems relate to one another. So the work we were doing on the shuttle and the flight system for that has already basically given us the sublight flight model we need for the main ship, because the flight controller already understands how RCS thrusters work, and the autopilot in there can automatically already point the nose of the vessel at a given vector in space. And it can do that purely by firing the RCS thrusters and then keeping the nose on target via those RCS thrusters. And that was the piece of the puzzle we needed that was basically stopping us from implementing the full sublight model for the main ships, because we can't do that until the autopilot's working, basically. But now that is working, we've already solved sublight flight. So that bit's done. The galaxy bit's done. The next thing that just needs to be connected up is things in space spawning a proxy of themselves so that you can see them out the window. And this all comes back to the fact we move space around the ship. The ship interior is static, we move space around it. But because we move space around it, and space is the thing that's moving, anything that is physically simulated, like a rock or a ship or a planet, exists in an invisible space that runs the physics simulation. But of course you need a visible representation of that you can see outside the window. And that visible representation needs to know which ship you're on, so that it knows what orientation and location to move the starfield. So here's a couple of examples of the new stuff. So basically, the Genesis subsystem is the Galaxy Gen, and all we do, literally all we do, is we give it an origin point in light years. So this is, where are we in the galaxy? By sending this, it will then trigger off the entire process for generating the galactic space. Now it could be the case that you've just moved a single light year and it sorts the locations of stars. So it basically goes through all the stars and reproduces them with their distances updated. So the distance and the apparent magnitude are the 2 important things you care about every time you move 1 light year. So we've got, the system basically handles that. And then we've also got a ship registry subsystem where everything, like a shuttle, registers itself with the subsystem, and we have a vessel class which tracks all of the replicated data that shuttle would produce. How much power it's got, where it is, how fast it's going, which way it's facing, and all that stuff. But we have the same collection of data for the actual main starships. And as you move from starship to shuttle, or from starship to station, or from starship to a planet's surface, that ship registry subsystem needs to repoint everything outside of the window at a new vessel so that it knows which way it should be facing. So these are all the different pieces that have to come together to create a single coherent experience. And what I'm doing right now is I'm building and polishing the individual pieces. And then to go back to the original question, when is this going to be ready? Basically, once everything connects together and can communicate with each other smoothly, that's the point in which we put it out. First of all, as a dev build, then we'll go through our bug fixing process, and then we'll release it live to the public. I can't put a time frame on it. Any time frame I come up with would be wrong. So it's just a case that I'm doing it all day, every day, and I will continue to do so until it is done. That's how long it will take. But the point, I guess, is that all the different pieces are almost ready, and it's just a case then of just integration. As someone used the analogy on Discord earlier, it's like we're building the Lego bricks, and once all the Lego bricks are done, then we can build the house. What else? I think that was about it, really. Kit Havoc, great, I'm glad. Yeah, it's the game we always wanted to play, which is why we're building it. And yeah, I think not having VR would be a travesty. So yes, absolutely. Absolutely, definitely, we'll always build it with VR in mind. We've contacted Steam asking for a development kit for the frame, so hopefully they'll supply us with that. We're on 5.8 now, Miner. I went ahead and updated everything. So the star system creation tool will be part of the game client. So you'll be able to add your own star systems to the game or edit existing ones. And that's basically all going to be there on the main menu. Ideally, I'd like to add Steam Workshop support for that. So I need to look at what format this is outputted as and read as, because we need to make sure we get the format right so it can easily work with the workshop. Because then you can author a collection of star systems and then share them for other people to download. And the same with like ship customization. So if you have like a really, really nice ship customization that you've spent a long time tweaking, you'll be able to share that on the workshop. But we just need to work on the data structure. And yes, the demo update will have refueling. Yeah, comets will exist. I don't have a demo map for it at the moment because I replaced it with a different one. But basically, within a star system, it will work the same as it does for the galaxy itself. I can't remember whether or not I added debugs. Hang on, let me just see. Hurrah, it crashed. These crashes are because of the game state problem. So basically, once all this stuff is finished and connected together, I'm just deleting our old game state completely, just getting rid of it and making a whole brand new one. Because at that point, like literally the only thing it will be doing is probably handling the load and save process. Everything else will be running in its own class, in its own isolated area, which means we have no more dependency chains. It's funny because if I don't open game state first, I then can't do anything else. Like I have to open game state, let it compile, and then I can do other stuff. So it's just it's so bugged. So I'm looking forward to that moment that I can press delete and get rid of it. I just don't want to get rid yet until I've replaced everything, because you can be sure I'll forget something otherwise. Right, so now that game state has opened, and you can see there's very little stuff left on it, we should now be able to open our demo level without it crashing. Hurrah! So if we do that, I don't know whether I unhooked a bunch of the debug stuff, so I don't think it's going to draw the grids. Oh yeah, there we go. There's the grids. Right. So if I freeze the galaxy a minute. Right. So here you can see one of the stellar classes. I think that's probably the Bs, and you've got the 3 radius sphere of cubes, which are the cells that generate the actual stars themselves, and then the sphere in the middle, that's the actual culling region that the stars are culled with. Now the reason we are generating it with 3 cells radius is because we're not wasting space in the corners. So the cell generation region fits the sphere as closely as possible without having to generate too many cells. So basically anything outside of that sphere for that stellar class is culled, and that sphere should represent the apparent magnitude cutoff point. So that's how it works for the galactic space. But going back to comets and things, when we are within a star system, we have a similar system to this, which splits that star system into a similar set of cells, depending on the class of object. So if it's something reasonably big and large that we want to see from a great distance away, like a comet, then it would generate with really, really big cells. Maybe like 1 AU per cell, something really huge. Whereas something like a little asteroid may have like a 1,000,000 kilometer cell, so they don't generate at great distances. But that means by splitting star systems into cell regions like this, as you're flying through the star system, it's constantly generating content based on the seed of that star system. And the net effect of that is star systems can literally have trillions of objects within the star system, but they're only there when you're within their culling radius, right? As in within their cell. So we can have things like comets, hundreds of thousands of asteroids, and anything else we want to put in a star system, which are only there, when you're there with them. So yeah, that's a long answer for basically saying yes, we'll have comets. But that's how we'll have comets. So the things we're replacing, there was about 22 things I think we had to replace. A lot of it's stupid stuff. So it's things like the debug output system I wrote, because we can't have like debug text in a packaged game. So I wrote my own tool for that, so we can show debug messages in the game. I just had that sitting on game state, so that can just be its own thing. The multiplayer chat system, I built that on game state. That can be its own thing. The galaxy was the big thing that needed replacing. And the helm and ship state side of things were the other big thing, because all of the helm stuff flowed through game state. So pulling those two out was the big job. Everything else is just silly little things, like whether the player's brigged or not was being stored in game state. That's better put off on player state. There's a lot of things which just need moving somewhere else. But I figured I'd do the big job first and get this sorted. Plus, I like working on the galaxy, and it's a challenge not to fall down rabbit holes. Rogue planets are already a thing. Yeah, I wouldn't say it was a major setback. I mean, it was a major pain in the ass, certainly. But it's not really a setback. It's more a sidestep, if that makes sense. I mean, we could have cobbled together a fix for the game state, and basically just carried on as we were. But the thing is, we would be carrying corruption with us. So this is what happened a few months back, because we had this crashing problem, and we managed to fix the crashing by just shifting some components around and kind of moving things off of game state into their own class. And that kind of fixed the crashing. And then we thought, well, that was it fixed. But all we've done really is paper over the problem, because this is inherent bug corruption somewhere within our game state file, which keeps causing problems. So if we had just papered over the problem, it would have bitten us again at some point down the line. So it was better just to rip off the plaster and just remake it, which is what we've been doing. But yeah, this was the perfect opportunity to bring together all the individual pieces we needed for the different patch objectives that we have coming up, and build that as a coherent, connected system, modular, so nothing depends directly on anything else, so there's no reference chains. But at the same time, it's all kind of part of the same coherent system about representing a ship in space, and then being able to have shuttles and things and planetary surfaces. Like, all of that kind of all relates together. So by having a C++ based foundation for everything, it means that we can basically do it better compared to what we had before, which is, basically what we've done. So the galactic space is easily far superior to what we had 6 weeks ago. So I'm counting it as a win, even though it was a massive pain in the ass. Yeah, basically it was Delta's fault, so everyone can blame Delta. Yeah, I know exactly what the corruption is, and it's unfixable. The basically, we've got this galaxy location generator, and if I edit that, you can see that the event graph is completely blank. There's nothing there, and the only thing which exists on this component is this one single function, and within this one single function there is one single node, just this node here, and within this one single node there is a reference to our neutron star there and our procedural planet class there. If I remove either of those references, so if I were to set one of these to none, for example, it breaks the engine. If I delete this node, it breaks the engine. If I delete this component from game state, it breaks the engine. So something to do with this and the way it's connected to game state is broken. And it seems to specifically be the game state side, I think, because it's the game state specifically that I have to open before anything else will open. So we know exactly what's broken. We know how to make it crash consistently. So we just know basically that this functionality on here just needs separating out into its own individual classes, and then we no longer rely on game state the way we have been. And as I demonstrated in the last update stream, if I just go to our reference viewer, you can see the problem. The problem is that we have got an absolute butt ton of classes hanging off of game state, like this lot, basically. So all of these blueprints all have a hard reference to game state, and I think the reason this corrupted in the first place is because we were pushing too much stuff. Most of it's UI. It's like all this stuff, it's all just UI screens. And the problem is because we were using game state to replicate our network data, all the UI screens in the game we're all speaking to game state to access that replicated data. So it's just one of those things where we're just trying to put too much stuff in one class, and it's that whole too many eggs in one basket problem, and inevitably it got corrupted. Now fortunately, all of these UI panels, of which there are many different UI panels, they can now reference the ship registry directly, because in the new world, and it's probably worth me explaining this more so I can get my own head around it, because I keep confusing myself with this. It's quite a complicated system. But in a nutshell, we have a vessel class. That vessel class can be anything. A shuttle, a starship, a planetary surface, a space station, anything basically. More often than not, it's going to be a starship or a shuttle, which is why we call it vessel. That vessel class is the only place that stores the replicated data for that vessel. And any class that needs to access that replicated data has a single place to get that data. But nothing needs to cast to it, because it's all referenced via a subsystem. So the ship registry subsystem is where all these vessel classes register themselves. So they basically, as soon as the game starts, as soon as they're spawned, they speak to the subsystem and say, hey, this is me, this is my ship ID, this is a reference to my data. So all the other game systems need to do is they need to go to the subsystem and say, hey, which vessel class do I need for this particular vessel ID? So the subsystem says, you want this one, this is the vessel you need to be speaking to. And then that vessel class will spawn its physics actor, it will spawn its proxy actor, and it will basically collate all the data from all the individual hardware components that make up that vessel. So all the valves, all the pumps, all the fuel tanks, the reactor, all the electrical cables, the electrical switches, basically all the data for all of those things are all replicated through this vessel class. So it's much more streamlined. And because we're using fast array serialization, which is something you can only do in C++, it means that it's only replicating the stuff that changes rather than replicating the entire array. And some of the issues we've had, like with the sensors, and like when you press a button on the sensors in multiplayer, for clients it can be quite laggy because there's so much data being passed over the wire unnecessarily that it's basically just saturating the link. By using fast array serialization, what we can do is make sure that things like the sensors and things like the hardware on the ship, they're only replicating things that actually change. So if you've got like 1,000 cables all in one giant array, normally when you change the data in one of those array entries, the entire array will replicate. Well, what the serialization does, it will only replicate that one cable when it changes its state. So there's lots of little things like that behind the scenes which are improving things across the board. So it's going to be more stable, the network footprint's going to be much smaller, everything's more centralized and organized. It's just better across the board. So we've taken this corrupted game state to be basically a point to step back and say, right, enough's enough, let's just fix everything. Take all the lessons we've learned over the past 5 years or so and just build a really nice, strong, stable foundation where we can build the rest of the systems. Because obviously we've got a picture that we have for the project for early access. We know what systems we need, we know what gameplay we need, we know what we need to implement for early access. So what we're doing right now is building a really strong foundation for all of those individual things that we know we need for early access. And that's basically where we're at. So essentially the next dev build we put out will be when those things are connected together, and actually the game will play exactly as it does now on the current dev build, only better with a much more accurate galaxy. That's kind of where we'll be in the next build. But yeah, I just need to keep doing it, basically. So that's where we're at. So I shall leave you with this. In fact, if I unfreeze that, you can see that as we're going through space, like it's constantly generating all those cubes as we go. Right. And you'll notice that it doesn't matter how fast I go, there's absolutely no hitching or lag whatsoever. And that's just a big win. And I'm moving through the galaxy way faster than the ship ever will. So yeah, again, it's a big win. So as demo out and out the way, because it's becoming a bit of a chain around our necks, this demo. Once it's done, it's polished, it's released. After the demo release, we're basically full bore towards early access. So the development streams are going to be focused on getting to early access. And yeah, so basically once the demo update's out, streams will return to normal. Okay, well, unless there are any other burning questions, I shall leave it there. Thank you once again, everyone, for sticking with us. I know it's been a long couple of months while we've been kind of working on this stuff, and we've not been putting dev builds out because everything's in pieces right now. So yes, thank you for your patience. Thank you for sticking with us, and hopefully this gives you sort of some small insight as to what we're actually doing right now. And yeah. It's going to be awesome, and it's going to be so much better than it was. So, yay. Alright, have a good one, everyone, and I shall see you on the next update stream. Bye for now.